Hello grade 7 learners, it's Math O'Clock again with teacher Catherine. Are you ready for our lesson for today? That's great! So what are we waiting for? Let's start! You've learned about irrational numbers, so this time we will be discussing estimating square roots to the nearest hundreds. At the end of this lesson, you should learn how to estimate the square root of a whole number to the nearest hundred and plot irrational numbers on a number line. But before we proceed with our lesson, let us test how much you've learned on our previous lessons. We have here three radicals. Your task is to find the square root of each number. Write your answers on your paper, and you have 10 seconds to answer. Go! Stop. For square root of 1, the answer is 1. How about for the square root of 25? You are right. The square root of 25 is 5. And the square root of 100 is? Correct, 10. Great job, grade 7 learners. You really listened to teacher Lori last time. Since we obtained whole numbers as the square root of 1, 25, and 100, these numbers are called perfect squares. What if the numbers are not perfect squares? Do you think it would be easy for us to identify the square roots? Say, for example, the square root of 7, the square root of 73, and the square root of 125. With the use of calculators, that is very easy, but we should also learn how to do it manually. Let us have another activity that will be very helpful for our topic. This activity is titled Perfect Match. Match the radicals in column A to the nearest two integers where its square root lies in column B. For column A, we have the square root of 8, square root of 40, square root of 67, square root of 3, and square root of 20. Look for the pair of integers where the square root of these radicals lie. Again, you have 10 seconds to answer, and your 10 seconds starts now. Time's up. For square root of 8, it is located between 2 and 3, so the answer is C. For number 2, the answer is E, 6 and 7. 3, the answer is D, 8 and 9. 4 is A, 1 and 2. And for number 5, we have letter B, which is 4 and 5. Now, let us apply this in estimating square roots. For our practice, let us try estimating the square roots of 7 and the square root of 73. Let us have first square root of 7. So for step 1, find the perfect squares closest to the given number. The given number is 7. Since 7 is not a perfect square, we need to find two perfect squares that is closest to 7. As we can see with the series of integers, the perfect squares closest to 7 are 4 and 9. From here, we can say that square root of 7 is between square root of 4 and square root of 9. We all know that square root of 4 is 2 and the square root of 9 is 3. Therefore, square root of 7 is located between 2 and 3. Since 7 is closer to 9 than 4, we can say that square root of 7 is closer to 3 than 2. For step 2, make an educated guess to one decimal place and try it. Since we know that the square root of 7 is closer to 3 than 2, we then square numbers closer to 3 with one decimal place. These numbers are 2.5, 2.6, 2.7, and 2.8. 2.1, 2.2, 2.3, 2.4 are no longer included in our list because when rounded off, they are no longer equal to 3. Square each number. 2.5 squared is 6.25, 2.6 squared is 6.76, 2.7 squared is 7.29, and 2.8 squared is 7.84. With the results, let us now check which is closest to 7. 6.25 and 7.84 are no longer included. The results nearest to 7 is 6.76 and 7.29. After determining the closest squares to 7, let us decide which of the two is closer. For this step, let us disregard the radical sign for the meantime. Let us subtract 6.76 and 7.29 from 7 to check which is closer to 7. 7 minus 6.76 is 0.24. 7.29 minus 7 is 0.29. So which is closer? Correct. 6.76 is closer because the difference is 0.24. Now we all know that 6.76 is the square of 2.6. Therefore, 2.6 is closest to square root of 7. Since 7 is closer to 6.76 compared to 7.29, and 6.76 is the square of 2.6, then estimate further by squaring the numbers 2.61, 2.62, 2.63, 2.64, and 2.65. Squaring 2.66, 2.67, 2.68, and 2.69 is not necessary since the square root of 7 is closer to 2.6 than 2.7. After squaring each number, we will obtain the following result. With the results, which do you think is closest to 7? Correct. 7 is closer to 7.0225 compared to 6.9696. Meanwhile, 7.0225 is the square of 2.65. Hence, the square root of 7 is 2.65 when estimated to nearest hundredths. Now, after estimating the square root, let us try plotting irrational numbers in a number line. In doing this, we estimate first the square root of the given irrational number and to which two consecutive integers it lies in between. Since we are done estimating the square root of 7, we know that the square root of 7 is approximately equal to 2.65 and it is located between the integers 2 and 3. So let us estimate the location of 2.65 and there we have it, the location of the square root of 7 in the number line. Easy, right? Let us try another one. This time, I want you to try it also on your scratch paper. For example 2, let us estimate the square root of 73. Again, for the first step, find the perfect squares closest to 73. And what are they? Correct! The perfect squares nearest to 73 and 64 are 64 and 81. So what does this imply? Correct. The square root of 73 is between the square root of 64 and the square root of 81. In other words, it is located between the integers 8 and 9. To which integer does the square root of 73 closest? Correct. It is closer to 9 since 73 is closer to 81 as compared to 64. Now, let us make an educated guess to one decimal place. Think of integers with one decimal place that when rounded off, it will be equal to 9. So we have 8.5, 8.6, 8.7, and 8.8. Note that we need to include only numbers that is close to 9. Let us now square them. 8.5 squared is 72.25. 8.6 squared is 73.96. 8.7 squared is 75.69. 8.8 squared is 77.44. Let us now see which among the results is closest to 73. Correct, 72.25 and 73.96. 75.69 and 77.44 are no longer counted because they are far from 73. After eliminating some of the numbers, which is closer to 73, 72.25 or 73.96? Let us see if your answer is correct. Subtracting 73 and 72.25, the result is 0.75. Okay, 73.69 or 96 minus 73 is 0.96. It is very clear that 73 is nearer to 72.25. Thus, square root of 73 is closer to square root of 72.25. We all know that the square root of 72.25 is 8.5. Now let us add another decimal number to 8.5. Choose decimal numbers which are closer to 8.5, then square it. So we have 8.51, 8.52, 8.53, 8.54, and 8.55. After squaring, which do you think is closest to 73 among the results? Correct. 72.9316 is closer as compared to 73.102. Therefore, the estimated square root of 73 is 8.54. And in a number line, the square root of 73 is located almost midway of 8 and 9. So did you get the same answer and illustration, dear learners? That's great! So today you learned about estimating the square root of a whole number to the nearest hundred. And you also learned about plotting of irrational numbers on a number line. Keep this in mind because you will use all of this as you explore more exciting lessons for grade 7. I hope you learned a lot today. Again, this is Teacher Catherine. Thank you for watching. Keep safe and God bless everyone. Goodbye.